What's up, interweb? This is a review from class meeting Tuesday the 29th, and it was the zeros of a polynomial function. Now, first of all, one of the things I forgot to mention was what is a polynomial? Poly just means many, nomial just means numbers. So, and zeros, roots, and solutions all mean the same thing. I don't know what they're going to ask you for on the final exam, but zeros, roots, and solutions all mean the answers. Now, is x minus 1 a factor of all this? And the way we do that is we do, well, that's not working either. How about that? We do synthetic division, and if, excuse me, if it doesn't have a remainder, if it does not have a remainder, then it is a function. This would be a function, or I'm sorry, a factor of all these F words. No, not that F word. This is a factor of this. Now remember, when we have, excuse me, f of x equals 2x to the fourth plus 3x squared minus 5x plus 7. Do we have all of the do we have all the terms here? No, we're missing a term here. Remember, it has to go excuse me, the fourth power, third, second, first. Okay, so we're missing the cubic. So it should be 2x to the fourth plus 0 x cubed plus 3x squared minus 5x plus 7. Okay, this is what we're going to use as our dividend for our synthetic division. Now remember, in order to get the divisor, we set x minus 1 equal to 0, so therefore add 1 to each side. X is 1. Now we have 1 on the outside. Now we take all the coefficients of the numbers in front of the letters. So we have 2, 0, 3, -5, and 7. Bring down the 2. Now we do 1 times 2. 1 times 2 is 2, isn't it? I think something like that. Okay, 1 times 2 is 2. We put the 2 here. Now we add these two together. That's 2. And again, 1 times 2 is 2. We add these two together. We get 5. 1 times 5 is 5. And we add, excuse me, we get 0. Does that mean it's a factor? No, we still have this one that we have to bring down. 1 times 0 is 0. We add those two together, and we have a remainder of 7. So is this one is x minus 1 a factor of all this misery? No, because it has a remainder. And the quotient here, the answer would be 2x cubed. Remember, we're going to reduce the exponents by 1, plus 2x squared plus 5x plus 7 over x minus 1. So no, not a factor. A-C-T-O. Okay? Okay. and so on. I'm not going to bore you with any more of those. Okay, now the rational zeros yes, Miss Montoya, I'm moving my paper up. Rational zeros theorem. I put a little line through here to make to distinguish it from a 2 because my handwriting's so bad. Rational zeros theorem. Now, first of all, rational numbers can be written as any fraction. Okay. Now, to find the rational zeros of a factor, to find rational zeros of factors, A-C-T-O-R-S, are plus or minus P over, and I'm going to use capital letters here because my handwriting's so bad, but what I'm doing is wrong. P over Q. Where P is the constant of the polynomial, P-O-L-Y, and Q is the coefficient, O-O-E-F-I-C-I-E-N, of the leading, or you can say the first term. Now this is the definition, I think this is the definition from the book. Does that make a whole heck of a lot of sense? Not really. So if we have, for example, e.g., if we have f of x equals 2x cubed plus 5x squared minus x minus 6. Okay, if we have this, this is our p, and not necessarily the negative part, just the 6. And 2 is the q. So in this one, the rational zeros, so in this particular example, our rational zeros, R-A-T-I-O-N-A, our rational zeros, E-R-O-S, are factors, F-A-C-T-O, of P over Q. Okay? So P is 6 or negative 6. Actually, they're plus or minus. And Q is plus or minus 2. So now, excuse me. Okay, so we have this. We have 2x cubed plus 5x squared minus x minus 6. Okay, are we missing any terms here? No. So our P here, remember it's P over Q. Our P is 6, actually plus or minus 6, over plus or minus 2. So what are the factors of 6? We have, now all these are plus or minus 1, 2, 3, and 6. Okay, what numbers will divide evenly into 6? 1, of course. 2 will go into 6 evenly, 3, and of course 6. Divided by, what are the factors of 2? Plus or minus 1, and plus or minus 2. Okay, so our possible roots are, excuse me, B, L, E are possible. These may be the roots of, possible roots are, okay, first we're going to start with the numerator. That'll be, and the denominator, we're going to use just the 1. So we're going to have 1 over 1, actually plus or minus. Then 2 over 1, we're going to distribute all of this stuff over 1. 2 over 1, 3 over 1, and 6 over 1. Right. Now we do the same thing with the 2. We have 1 over 2, 2 over 2, 3 over 2, and 6 over 2. Now, if any of these numbers repeat after we reduce the fractions here, we only have to include it once. So we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 1/2. Now 2 over 2 is 1, and we already have 1, so we don't need to repeat it. 3 over 2, plus or minus 3 over 2, and 6 over 2 is 3, and we already have that, so we don't need to repeat it. Those are our possible roots. Now, how do we find out if they are? First, you take a drink of your Diet Coke. Now remember, these are the possible roots. They don't necessarily mean that they are the roots. Those are just possible ones. Now we use these using synthetic division to find out if they are in fact factors. Okay, and remember our okay, so we have, what do we have here? We have, first we're going to take 1 as the divisor, and we're going to have, we're going to take the coefficients of all these. So we have 2, 5, -1, and -6. Bring down the 2. 1 times 2 is 2. Add these together. 7. 1 times 7 is 7. -1 plus 7 is 6. Now we do 1 times 6 is 6. Oh, look at there. And that's a 0. So is this a factor? Or is 1 a factor? Or a root of this? Yes. So we have, remember now we're gonna reduce our exponents by 1. So we're gonna have 2x squared. Yes, I'm moving it up, Ms. Montoya. How about that? I saw that all by myself. 2x squared plus 7x plus 6. So is this a factor? Yes. And now what is our divisor? We have 1 there. So x equals 1. So what is our divisor? Subtract 1 from each side. X minus 1. So we have this divided by x minus 1. And that is a factor of that. Okay? Now, you have to do it to all of them, not just to one. But you can do that by yourself. Go right ahead. That's basically all there is to this. It's not particularly difficult. I think now you can see why we spent so much time on synthetic division. Because now I hope that synthetic division is kind of second nature to you. Pretty simple. Even I can do it sometimes. Okay, that's it. Have a good weekend. Bye-bye. Oh, it's not weekend yet. Bye-bye. Bye, bonds.